students, welcome back. So as you know, there are ample of reactions in your chapter acid, bases and salts. So let's collate all the reactions together and revise it in one shot. Let's go through it quickly. Beginning with the acid, okay. So we will see dissociation of different acids, the strong acid, the weak acid, monobasic acid and tribasic acid, everything. And also the bases, we will see the dissociation of bases too. First we understand the dissociation, how it dissociates into its ions, then we will come to the different reactions. So let's begin. So as you can see, your first acid which is there, HCl, okay, dissociates in water to form your hydronium ion H3O plus and your Cl minus ion. So HCl gives plus H2O gives H3O plus and your Cl minus ion. Simple? Okay. Let's move on to the base. The reaction of a base with an acid. So copper oxide is the base. The reaction with acid HCl will give you copper chloride, CuCl2 and your H2O, that is your salt and water, like your neutralization reaction. Let's move on to alkali. Okay, let's move on to alkali. Here as you can see, sodium hydroxide, okay, sodium hydroxide dissociates to form sodium ion Na plus and hydroxide ion OH minus. This is important. This is how your sodium hydroxide dissociates. Clear? Then let's take an example of strong acid. With strong acid we can take HNO3, okay, that will dissociate in water to form same hydronium ion, just like we found it here, hydronium ions and your nitrate ion, okay, NO3 minus. Now H2SO4, same thing, formation of hydronium ion will be there, hydronium ion, but this time sulfate ions. So as you can see, the corresponding ions are formed, nitrate ion, sulfate ion, and this H and H2O will form the hydronium ion H3O plus. Clear? Let's move on to weak acid. So the very common example of weak acid we take is acetic acid. So CH3COOH. How it dissociates in water? Now why is it called weak acid? Because it does not dissociate completely in water. Okay, so even if it dissociates partially in water, how does it dissociate? It dissociates like this: CH3COO minus, okay, this part and your H plus ion, and since it is giving this H plus ion, we call it as acid, right? Okay. Moving on to strong alkali now. Okay, now alkalis are going to give me hydroxide ions and not hydrogen ions. Let's see, sodium hydroxide gives Na plus plus OH minus. Simple. Hydroxide ion, KOH will give me K plus plus OH minus. Let's take weak alkali. The very common example, always remember, ammonium hydroxide. Okay, is the very common example of your weak alkali. Again, it does not dissociate completely and that's why it's called as weak alkali. But how much ever it dissociates, it will form what? Ammonium ions, NH4 plus plus OH minus, hydroxide ions. Since it is giving us OH minus ions, we call it as an alkali. Clear? Okay. Now, let's see how monobasic acids dissociate in water. Okay, example monobasic acid, common example HCl plus H2O will give me hydronium ion H3O plus plus Cl minus ion. Now what differs here? Now let's see how NaOH reacts with your HCl. So you will get, this is a base, this is an acid. So what you will get, because of neutralization reaction, you get salt and water, right? So this and this comes together, this and this comes together and water is formed. Moving to dibasic acid. Okay, dibasic acid, as you can see, H2SO4. So here one H is there, so monobasic, two H is there, so dibasic. Simple. Okay, requires two molecules of water, dissociates and forms hydronium ions plus SO4, 2 minus, sulfate ions. How many hydronium ions? 2. Understood? Moving on, reaction of the same with your base. So what will happen? Base plus acid will give salt and water. With salt, NaHSO4, sodium hydrogen sulfate plus H2O. Clear? Moving on, let's take sodium hydroxide, but two molecules of sodium hydroxide reacting with this. Sodium sulfate you are getting, not hydrogen sulfate, sodium sulfate, and this part will come together as 2H2O. Okay, so it differs, right? It differs. Moving on, tribasic acid. So which example? H3PO4. How many hydrogens? 3 hydrogens. That's why tribasic acid. Simple. How many molecules will be required? 3 H2O. And how many hydronium ions will be formed? 3. So try everywhere 3, 3, 3. Simple. Okay. This leftover ion is your phosphate ion PO4 3 minus. Is that clear? Okay. I hope that's clear to you how tribasic acid dissociates in water. Okay, reacting the same with a base. So base plus this acid will give me which salt? Sodium hydrogen phosphate. Okay, the name of the salt is NaH2PO4, sodium hydrogen phosphate, the salt and the water. Clear how this is formed? This part and this part comes together, and this part. Okay, so you have to split that molecule. Moving on, sodium hydroxide excess. Can you see the molecules are changing? How many sodium hydroxide now? 2 NaOH plus H3PO4 will give me
Na2H PO4 is the
same product but 2 molecules and H2O. Okay, let's take 3 molecules of NaOH. Okay, 3 molecules of NaOH reacting with your phosphoric acid. Okay, phosphoric acid to give trisodium phosphate. Can you see that trisodium phosphate with the formation of water molecule? Clear? Let's take monoacidic base. So sodium hydroxide. Sodium hydroxide, first of all we have to see how it dissociates. So it forms Na plus and OH minus ions. Okay, and this is an example of a monoacidic base. Okay, monoacidic base. How many hydroxide ion? 1. Moving on, diacidic base. So CaOH twice. How many hydroxide ions? OH twice. Okay, that means 2 hydroxide ion, diacidic. This time how many OH minus ions will be formed? 2 OH minus ions, correct? So CaOH twice will give me Ca2 plus 2 OH minus. Clear dissociation of diacidic base. Okay, let's move on. Another example, copper hydroxide. Okay, will give me Cu2 plus 2 OH minus. Okay. Now we'll see the formation of acids from different reactants. So first we are going to take non-metals. So let's take one non-metal. Hydrogen, it's a non-metal. Chlorine, it's a non-metal. Both are gases. And what it will form? Hydrogen chloride, which is an acid, HCl, hydrochloric acid. Understood? Very simple reaction. H2 plus Cl2 will give me 2HCl. Okay. Let's move on. H2 plus I2 will give me 2HI, hydrogen iodide. Okay. Then acids from acidic oxide. Now what are acidic oxide? You can take carbon dioxide, nitrogen dioxide. These are all acidic oxides, right? So CO2, that is a carbon dioxide, the very basic carbon dioxide. Yes, it reacts with water to form H2CO3, a carbonic acid. Okay, just like we have in cold drinks. So your carbon dioxide dissolves in water, form H2CO3, your weak carbonic acid. SO2 dissolves in water, forms what? Sulfur dioxide will react with your water to form sulfurous acid, H2SO3. So can you see formation of acid from your acidic oxides? Okay. Another SO3, when SO3 reacts with your water, it will form H2SO4, your proper sulfuric acid. Next is what? Your P2O5, phosphorus pentoxide, reacting with your water to form phosphoric acid. Okay. So 2H3PO4. Let's review the reaction. P2O5 plus 3H2O gives 2H3PO4. Okay. Now let's make acids from salt. Okay. So as we know that acid and base gives us salt. How do we get acids from salts? So let's see. This is your salt KNO3. And you have to react with concentrated H2SO4
less than 200 degrees Celsius.
This is the temperature, and you get what? Your acid, nitric acid here. So from the potassium salt, you are getting nitric acid. From the potassium salt of nitrate, KNO3, potassium nitrate. Okay, KNO3 plus H2SO4 gives what? KHSO4, and our main product is the acid HNO3. Let's move on to the next one, NaNO3, that is your sodium nitrate. Just like we took potassium nitrate, let's take sodium nitrate. Okay, so your sodium nitrate reacts with your sulfuric acid H2SO4, that is your strong acid, at the temperature of
less than 200 degrees Celsius
to form your sodium hydrogen sulfate NaHSO4 plus your nitric acid. So your NaNO3, that NO3 forms the nitric acid. I hope that's clear to you. Let's move on to the acids by oxidation of non-metals. So when non-metals get oxidized, let's take an example. Sulfur, which is a non-metal. Oxidation requires a strong oxidizing agent, which is the strong oxidizing agent here, nitric acid. Sulfur plus nitric acid. See the reaction now. You get H2SO4, your sulfuric acid, plus your 2H2, that is your water, plus your NO2 gas will be evolved. So see the reaction properly. Okay, H2SO4. So did you get acid from a non-metal, oxidation of non-metal? Yes. Let's move on. Now we have come to bases. So let's see the reaction of bases. How do we form bases from metals? So let's take a metal, sodium, and simply react with oxygen, react it with oxygen and you get sodium oxide. Metallic oxides are basic in nature. Remember that. Metallic oxides are basic. That's why we have got a base Na2O. Let's see another reaction. 2Mg plus O2 gives 2MgO. Okay. Next, bases from basic oxide. So let's take this as the reactant now. Okay, and form another base. So the other base could be what? Hydroxides, right? So you are taking the base potassium oxide, reacting it with water to form potassium hydroxide. Again, this is hydroxides of metals are also bases, right? So KOH is a base, a very common alkali, we know that, right? How is it formed? From the metallic oxides, which are again basic in nature. So K2O plus H2O will give me 2KOH. Similarly, Na2, see, we are using this product as the reactant here, reacting it with water, and what we are getting? A base, NaOH, which is a very, very common base. Okay, now getting base from active metal and water. Active metal, which comes in active metal, your sodium metal, potassium metal, these are all active metals, right? So let's take potassium as the metal, reacting it with water, H2O, and what you will get? KOH plus H2 gas will be evolved. Okay, the same reaction which we saw, but this time we are taking the pure metal instead of metal oxide. Can you see? And in this reaction, when you take a direct active metal, there will be evolution of hydrogen gas. Okay, let's move on to the next one. 2Na plus 2H2O will give me NaOH plus H2. Same thing. Okay, reacting active metal with water, and you are getting a base, sodium hydroxide, with evolution of hydrogen gas. Moving on to the bases from salts. Okay, so how do we get bases from salts? So this is the salt, aluminium chloride. Okay, we are using another base of aluminium, that is aluminium hydroxide. Okay, so what is happening actually here, the double displacement reaction is taking place. How come? So as you can see here, aluminium is reacting with this and sodium is reacting with this. So you are getting sodium salt and aluminium hydroxide as the precipitate. So I hope that is clear to you. Let's see the next reaction, that is with your iron sulfate, okay, FeSO4. Now as you can see, FeSO4, what you are getting is FeSO4 reacting with your NaOH to give Na2SO4 and FeOH twice. Simple. Are you getting base from the salt? Yes. Moving on. Bases by decomposition of salt. So salts will decompose this time, that one salt will break down and form the base. How? So this is one salt, lead nitrate, PbNO3 twice. Okay, it will break down into several products. See the products, PbO, which is your base, okay, lead oxide, then NO2 gas will be evolved and remaining O2 gas will be evolved. Can you see one reactant, three products getting formed, one of the products is the base. So this is how you form a base from the decomposition of salt. Remember to take the salt, lead nitrate. Moving on, reaction of chlorides, nitrates, bicarbonates and carbonates with acids. So how these things will react. So two examples we will see of each. So first we will take chloride. So we can take very common example, sodium chloride. React it with what? Acid. Which acid? Concentrated sulfuric acid we are taking. What are we getting? This part, NaHSO3. Can you see that? NaHSO3, and this part, HCl. Can you see this acid again getting formed? Which acid? Hydrochloric acid, because we are using the chloride salt of sodium, correct? So NaCl plus H2SO4 concentrated in, see the temperature,
less than 200 degrees Celsius.
NaHSO3 plus HCl. So your sodium chloride reacts with your sulfuric acid, concentrated sulfuric acid, to form in, see the temperature also,
less than 200 degrees Celsius.
From your NaHSO4, okay, plus HCl, your hydrochloric acid. Simple. Let's move on. Sodium nitrate, NaNO3, sodium nitrate, NaNO3, okay, reacting with your H2SO4, same temperature,
less than 200 degrees Celsius.
And what you are getting? NaHSO4 NaHSO4 plus HNO3. Clear? Nitric acid. So you got hydrochloric acid, you got nitric acid here, depending on the salt which you are taking. Clear? This is the nitrate. Next is what? Bicarbonate. Let's take the bicarbonate, NaHCO3, reacting it with the acid, and what you are getting? NaSO4, Na2SO4, sodium sulfate plus your H2O. H2O will be formed, and this, as you are taking carbonate, always remember, whenever you are taking carbonate, you will get carbon dioxide gas. Correct? Whenever you are taking carbonate here, you will get carbon dioxide gas. Nitrate will not form nitrogen dioxide. It's reacting and forming your nitric acid, hydrochloric acid. Here you are getting what? Carbon dioxide gas. Okay, let's move on. Let's take now carbonate. Okay, another carbonate. This was sodium hydrogen carbonate, or you can call it as sodium bicarbonate, and here we are taking sodium carbonate, Na2CO3, simply sodium carbonate, reacting with your dilute hydrochloric acid to form NaCl, sodium chloride, plus your H2O plus your carbon dioxide gas. So as soon as you take the carbonate salt, you get carbon dioxide gas getting evolved. Simple? Yes? Okay. Let's move on. Formation of acid rain. Very, very important concepts, and the reactions are also very important. The concept is very clear to you, right? So let's see the reactions. When sulfur in the atmosphere get mixed with oxygen, first of all, what is formed? SO2 sulfur dioxide, which is a pollutant, correct? Then this sulfur dioxide reacts with water, that is your rainwater, and forms the acid sulfurous acid, H2SO3, not H2SO4, because we have this SO2 here. If there was SO3 here, we would have got H2SO4. Okay, this is sulfurous acid. Why aqueous? Because of course it is dissolved in water and comes down in the form of acid rain. Simple? Okay. Now this SO2, can you see this? This 2SO2 which is there reacts with excess like more of oxygen to form SO3. This SO3 will dissolve in water and form what? H2SO4. Review the reactions quickly. 2SO2 plus O2 gives 2SO3. This SO3 will react with H2O to form H2SO4 aqueous, that is your sulfuric acid. Okay, so sulfurous acid, sulfuric acid. Moving on, nitrogen. Nitrogen gas which is there in the atmosphere already, oxygen is there, it might form very high temperature is there, it will form NO. Nitrogen fixation happened. So 2NO, correct? This NO, okay, this NO will react with your oxygen and form NO2 also. This NO2 will dissolve in water. Okay, so what will be the reaction? H2O plus 2NO2, which was from here, will give you what? HNO2 and HNO3, which is a mixture of your nitric and nitrous acid. Okay, preparation of acid. See the reaction, neutralization reaction. So as you can see, a base and an acid will react to form salt and water here. So the base is copper oxide, acid is H2SO4, simple. This will go with this CuSO4 and H2O, simple, salt and water, copper sulfate. How you got copper sulfate? By reacting copper oxide with your sulfuric acid. Moving on, lead oxide with your nitric acid, what will be formed? PbNO3 twice, lead nitrate and H2O, salt and water. Next, copper hydroxide, see the reaction, okay, hydroxide with your H2SO4, sulfuric acid. Salt will be the same, CuSO4, only the number of your water molecule will change. So from H2 it is 2H2O. Simple, we saw this reaction earlier as well. Lead hydroxide reacting with nitric acid will give me what? Lead nitrate plus 2H2O, because hydroxide is there here. Clear? Carbonate. So whenever there is carbonate, carbon dioxide gas will be released. So lead carbonate plus HNO3, your nitric acid, PbNO3, lead nitrate, same thing, water, same thing, carbon dioxide extra. Why? Because we use carbonate here. Simple? Okay. Zinc carbonate, HNO3, zinc nitrate, ZnNO3 twice plus H2O plus carbon dioxide gas, because carbonate is here. Copper carbonate, H2SO4, CuSO4, copper sulfate plus H2O plus carbon dioxide gas will be evolved. Okay. Let's see the titration, the neutralization reaction where titration is involved. So here we use basic acids and bases, like basic, that kind of basic, like simple. Okay, so we use the very simple acid NaOH, HCl, the commonly available one, so that we can do the titration. Okay, so let's see what is the reaction. NaCl plus H2O. Very simple acid-base reaction and the neutralization reaction, correct? Now this NaOH when reacting with nitric acid will form NaNO3, sodium nitrate plus H2O. Ammonium hydroxide, your weak base which is there, reacts with your acid to form NH4Cl, ammonium chloride plus H2O, corresponding salt and obviously water. Sodium carbonate, as soon as there is carbonate, what will happen? Carbonate, sodium carbonate and H2SO4, NaSO4, Na2SO4 plus your H2O will be there plus your carbon dioxide gas will be released. Okay, ammonium carbonate, this time you are taking ammonium carbonate plus HCl. So what will happen? Ammonium chloride plus H2O plus carbon dioxide gas. Simple. Ammonium carbonate plus H2SO4. Only this will change, the salt will change. Ammonium sulfate will be formed instead of chloride. Chloride, when you take hydrogen chloride, so obviously chloride salt. Hydrogen sulfate, that means sulfuric acid, so sulfate will be formed. Ammonium sulfate, H2O plus CO2 gas will be evolved. So this is how neutralization takes place. Okay, let's come to the simple displacement reaction. Okay, what is happening? A simple displacement. So your ion H2SO4, one ion is getting displaced. So this Fe is coming here and H2 will be evolved. As simple as that. One ion H2 is getting displaced by your Fe, iron. Moving on, Fe. Fe plus HCl, again same thing. FeCl2 plus this H2 gas will be liberated. Zn plus H2SO4, ZnSO4, H2. Mg plus HCl, MgCl2 plus H2. Okay, let's come to the direct combination reaction wherein two substances combine to form one product. So Fe plus Cl3, 2 Fe plus 3 Cl3 will give me 3 Cl2 will give me FeCl3, 2 FeCl3, iron chloride salt. Okay, mixing your iron with the chlorine gas. Simple. Aluminium with chlorine, AlCl3. Iron with sulfide, FeS. Okay, iron sulfide. Simple. As the precipitate. Zinc plus sulfide, ZnS, zinc sulfide as the precipitate. Lead plus sulfide, PbS, lead precipitate. These are all combination reactions. Two things combine to form a single product. Let's move on to double decomposition reaction where every time you will see the formation of a precipitate. Simple, a precipitate will be formed. So lead nitrate plus your NaCl, correct, will give me what? NaNO3, sodium nitrate plus lead chloride, PbCl2. Now how double displacement? Two ions are getting displaced. This, see, how do we consider? Lead is a metal positive, this is a negative radical, sodium is a metal, chloride non-metal. This positive will go with the negative of this positive will go with the negative of this. So the ions are getting displaced, so it is a double displacement reaction. See the reaction. Okay, review the reaction. Let's move on. Next one. Calcium chloride CaCl2 plus Na2CO3. So CaCl3 NaCl. Simple double displacement reaction. ZnSO4 plus NH4 CO3 ammonium carbonate will give me what? Zinc carbonate as the precipitate and your ammonium sulfate, NH4 twice SO4. It will give me what? Ammonium sulfate plus ZnCO3. Okay, let's move on. Zinc nitrate, ZnNO3 plus your NO2CO3. Double displacement reaction, what will happen? NaNO3, okay, and ZnCO3, zinc carbonate as the precipitate. Simple? Okay, moving on. Lead nitrate plus Na2SO4. Okay, lead nitrate plus Na2SO4. So how it will go? PbSO4 as the precipitate and your NaNO3. Review the reactions. Okay. Let's move on. Preparation of PbCl2 from PbO. So you need to form the salt lead chloride, okay, from your lead oxide, the base. Okay, forming salt from the base, remember that. So oxide will react with acid. Okay, so Pb will always form what? Lead nitrate, the very common salt, and your H2O. Then what will happen? Take the lead nitrate again, lead nitrate, and react it with what? This salt reacts with another salt, NaCl. And what will form? NaNO3 and your PbCl2 as the precipitate. So see how we formed PbCl2 from this PbO. Clear? Now Pb sulfate, lead sulfate from your lead carbonate, lead sulfate from lead carbonate. Let's see how do we form this. So we are going to take lead carbonate, react it with nitric acid to form the salt PbNO3 twice, that is your lead nitrate. Okay, lead nitrate plus your H2O plus CO2 gas will be evolved as there was carbonate here. We saw this reaction earlier also. Then let's take the reactant, let's take the product as the reactant, your lead nitrate plus Na2SO4. See, the salt is changing. This time we took this, now we are taking sodium sulfate. Okay, so NaNO3 and you will get what? Lead sulfate. Since we need to form sulfate, we use the salt of that kind. Since we wanted chloride, we would use a salt with that, so that this goes with this, in double displacement reaction, this ion goes with this ion and we are left with these two ions and form the product which we want. I hope that's clear to you. Yeah, let's move on. Now let's see, if we want to form lead chloride from lead carbonate, what we'll do? Same thing, we'll take the lead carbonate, react it with nitric acid, you will form you will get the PbNO3 twice, that is your lead nitrate, your H2 and your carbon dioxide gas as your gas which will be evolved, right? Then what you are going to do? Now tell me, you need what? Cl2 from this. So I am going to react it with sodium chloride, right? Sodium chloride. So what will be formed? PbCl2 and your NaNO3 will be taken out. Simple. This is what we wanted from this, correct? Yeah. Let's move on to hydrolysis of salt. What is hydrolysis of salt? It is somewhere neutralization reaction in a reverse manner. Okay, so basically when acid and base reacts, they form what? Salt and water. Okay, hydrolysis of salt means what? Salt and water reacting. So the what will be formed? Acid and a base, correct? So let's see the reaction. Let's see the reaction. You'll understand. This is what? Salt, ammonium chloride plus water. Okay, ammonium hydroxide plus HCl, acid. Ammonium hydroxide is a base. So did you see that? Hydrolysis of salt is exactly the reverse of your neutralization reaction. Moving on, NaHCO3 plus H2O. This salt, carbonate salt and then H2O. What will be formed? NaOH and your H2CO3, which is your carbonic acid, right? Another acid. So base and an acid. Na2CO3 plus H2O will give me what? NaOH plus H2CO3, carbonic acid, correct? NaCl plus H2O, this is a very basic reaction, your NaOH plus HCl. Basically for neutralization reaction we usually write this one, right? So for hydrolysis we write NaCl plus H2O, that is your NaCl dissolving in water, hydrolysis of salt, NaCl, acid and a base, correct? NaOH and HCl. So I hope that is clear to you. Let's see the last example for this. Magnesium chloride salt dissolves in the water H2O. Okay, see the molecules, MgCl2, so 2 molecules of H2O gives MgOH twice, the base, and the acid is 2HCl, okay, 2 molecules of HCl. So yes, this is the hydrolysis of salt. So with this we complete all the important reactions which are there in your chapter acid, bases and salt. Review it, go through it and keep revising. Thank you.